Okay. Show me.
Hi there guys, welcome back to the Dutch SC channel. Thank you very much for tuning in for another part in our perfect quadcopter build series. Yeah, and in the previous part we installed the latest firmware on our 4-in-1 ESC. Today, you've seen the title of the video, we'll be installing and configuring BetaFlight, the firmware for our flight controller. Yeah. And a basic configuration, that's what we'll do. We won't be setting up our receiver or our VTX, since I'm gonna be doing a separate video on those things in itself. So again, we'll be flashing the latest BetaFlight firmware onto our flight controller and do a basic setup of that. Let's get started. So for the setup of the firmware of our 4-in-1 ESC, we needed a LiPo, a power source. To flash the firmware onto our flight controller, however, we only need a USB cable to hook it up to our computer. And when we do, we will actually see our flight controller show up in the top right over here in the port section. There you go. COM port 15. So this is the BetaFlight configurator. With this piece of software you can configure the BetaFlight settings, but also flash new BetaFlight firmwares onto your flight controller. There is a link in the description of this video to the download page for this BetaFlight configurator in case you don't have it yet. So at this point we say connect, and yes, if you'd simply want to flash the new firmware onto your flight controller, you wouldn't connect, but I want to go to CLI over here, so click CLI and say version, click, and you will see, well, depending on your flight controller, you will see a flight controller name over here. And in my case, in our case, if you are building along with this build, that'll be the Mamba F7, right from Diatone, Mamba F7 flight controller. So that's what we need to know to be able to select the proper firmware for our flight controller. So now that we do know, we can say disconnect and move to the firmware flasher over here. By the way, in case you are wondering why we are doing the BetaFlight configuration at this point in the build, well, guess what? In a couple of steps we're going to be installing our receiver and VTX, and we're going to be configuring our receiver and VTX in BetaFlight. It's highly inconvenient to do that twice, right? So I first want to have the latest and the greatest firmware on my flight controller and then configure things. I hope that makes sense. Okay, as you can see, last time I did a firmware flash, that was actually for a Mamba F722 over here. Right, so I'm going to check if 4.1.4 is still the latest version, and it is. Yeah, it is. So by the time you are watching this video, there might be a later version for this flight controller. And yeah, I haven't tried that at the time I'm shooting this video, so I can't tell you if that's actually really better. Yeah. So maybe you are free to still select 4.1.4 even though there's a new one. That way you'll be sure that the firmware you will be using is the same as I'm using in this build series. Alright, let's see, I'm gonna load the firmware over here, so that'll download that firmware to your computer. And it then says loaded online firmware. It was pretty quick, I probably didn't even really download it because I already had it on my computer. Okay, at this point we can actually flash that firmware onto our flight controller. So we click flash, hartstikke. You will see the status over here change to DFU. In most cases, most modern flight controller, especially again if you're building along, this flight controller will automatically switch into DFU mode, bootloader mode basically, and in that mode the flight controller can accept new firmwares which it is now flashing. So again, we selected the Mamba F722. That's the flight controller we have. We selected the version we want to flash. We downloaded it to our local computer. And now we are flashing it actually onto our flight controller. Programming successful. Hachikide, as you can see here. That's wonderful, isn't it? Yeah. So at this point in time, what I always do is simply unplug the USB cable to reset the flight controller basically. So there, and plug it back in. There you go, and we see the COM15 show up again over here. And if all is well, when I now say connect, yeah, BetaFlight offers me the option of applying custom defaults, and that is definitely what you want to do. Otherwise you will have a super duper unconfigured flight controller. I'm not going to explain why or what, but since BetaFlight 4.0 or 4.1, the firmwares you actually download don't include the basic framework, the basic settings to make it actually work. If you don't understand, at this point you don't really need to, but the options you just saw that BetaFlight offers you to implement or load the default settings, that's what you definitely want to do. And okay, it has done so, reset the flight controller, and we can now reconnect. Hachikide. And well, okay, so what I'm gonna do now is again do a very basic rundown or pass through the options that I definitely know without installing a receiver and VTX and camera and such, right? So this is basically what I always do, also for instance when I get an RTF quadcopter in, the basic checks. So okay, the first thing I'm gonna do, even though I'm probably never gonna fly this quadcopter in auto level mode, but I'm gonna calibrate the accelerometer anyway. So what you want to do now is make sure that your flight controller is level, horizontally mounted if you will. So move around a little to have that happen. There. Okay. So now that my flight controller is completely level and I'm making sure to not touch it, my hand vibrations won't be fed into the flight controller. So I'm now going to click calibrate, and that's it. And for good measure I'm going to reset the Z-axis offset. Hachikide. Alright, that's all. And what you now do is check if the movements you see here, I'm moving the quadcopter around, are what you actually physically do with your quadcopter. So I'm now raising the nose. And you see in the diagram the nose is actually raised. I'm raising the back of the quadcopter, and I'm gonna turn it, yaw it left, yaw left, yaw right. I'm gonna bank it right, and I'm gonna bank it left, and that is it. So basic check. And if you are following along, you've installed the flight stack as it is intended with the arrow on the flight controller pointing forward. So this will work, right? So if you haven't installed your flight controller with the arrow pointing forward, you will, in the configuration tab over here, have to change, well, maybe the roll degrees, pitch degree, yaw degrees. Right, so depending on how you've mounted your flight controller. In our case, default. Very, very nice. Okay, now that we've established that our gyro works, we can have a look at our ports. The first tab on the left over here. I'm simply gonna, well, work my way through all these, well, most of these tabs over here. Okay, the ports, the UARTs, the COM ports of our flight controller. In this screen you set up how things will be connected to your flight controller. For instance, your receiver, your video transmitter, how it's connected to the 4-in-1 ESC partially. We'll see that in a second. And we've got that Bluetooth. This flight controller has a Bluetooth adapter built in. So that's basically, yeah, that's a bit of a weird thing. That's also connected. You'll see in a second. Okay, in a future video, actually in the next video, we'll set up and connect our receiver. However, as you can tell, UART 1 is already configured for your receiver. And this will be the S-Bus pad on your flight controller. So that's UART 1 and it's already configured for serial RX, and again, that'll be our receiver. UART 2 is not configured yet, and we'll cover that in the configuration of our receiver. However, I already know that I will use UART 2, COM port 2 for my telemetry. And telemetry, oh, over here. So that'll be IBAS telemetry over there. Hartstikke if you are using an FR Sky receiver, that'll obviously be FR Sky, right? In my case, IBAS. And again, we'll cover that once more in the configuration and setup of our receiver. UART 3 is not connected to anything yet, but I already know, and we covered that in the preparation of our flight controller. We'll connect our VTX to UART 3 for our smart audio. So peripherals, UART 3, smart audio. So with UART 3, we will be telling our VTX what to do, what frequency to use and what power output to use, right? So yeah, and we will cover that in a separate video coming up shortly. And let's see, yeah, UART 4 over here is actually reserved or used for our Bluetooth. This flight controller again has a Bluetooth adapter built in. With that Bluetooth adapter you can wirelessly configure the flight controller in the field from your phone. Definitely convenient. If you need that UART 4 for something else, you can, but you'll lose that Bluetooth feature if you disable it here. Right, I hope that makes sense. But again, if you want to use UART 4 for instance for your GPS, then you can, but well, you'll have to select UART 4 peripheral GPS. Where is that sensor input? GPS over there, right? I won't, but you can. Then UART 5, I won't be using UART 5, so that's definitely a vacant UART for future use for GPS, maybe, why not? That's definitely a possibility. And UART 6 isn't used or configured either, as you can tell. However, let me see, sensor input. Yeah, I will, this stack, this Mamba stack, this F722S stack with F50 flight controller does enable you to use ESC telemetry, as you can tell here. We will need, we will need that in a future video in which we can go and tune our quadcopter. It's not needed to fly the quadcopter, it'll fly just fine without ESC telemetry. Again, we will be using it and eventually the quadcopter will definitely fly better by using this sensor input over here. And it'll always be UART 6, at least in this stack, right? It's a physical connection on UART 6 for that ESC telemetry. Now, if you again need extra UARTs, you can, well, disable it over here and use that UART for another purpose. That's definitely possible, but obviously you will then lose, well, the features of ESC telemetry. So yeah, okay, so that's all our ports, and yeah, pretty filled up basically. The only UART that is not in use at this point in time is UART 5. Again, if I need more, I could disable that Bluetooth or ESC telemetry, or maybe receiver telemetry over here on UART 2. That's definitely possible if other features are more important to you. This will be the setup I'll be using in this tutorial. Right? Okay. And then we hit save and reboot. Alrighty, configuration, the next step, and let's see what we need to set up in this one. D-Shot 600. In the past, before BetaFlight 4.0, I would definitely have used D-Shot 1200, but as you can tell, that's no longer an option, and it's also not really needed. And I'll be using D-Shot 600. That is the language, the protocol with which the flight controller will talk to our 4-in-1 ESC. And it doesn't really matter what or how or when. The 600 in this D-Shot 600 references the speed at which the discussion between our flight controller and the 4-in-1 ESC will take place. Okay, so I already know that this will work in this setup. So I'll be using D-Shot 600. Maybe I'll do a separate video in the future about the differences and why you would pick one over the other. For now, we'll be using D-Shot 600. Motor stop. I want my motors to spin up once I arm the quadcopter. So yeah, by leaving this motor stop switch, well, default, that will happen. ESC sensor and bidirectional D-Shot is something we'll cover in a future video, and it's part of the tuning of our quadcopter. We don't need it, and the quadcopter will fly as it is, like you see it here, but in the future we'll make it fly better by using ESC sensor and bidirectional D-Shot. Then the motor pulse is important, and you will need to check if you are using different motors, you'll need to check if your motors, the specifications of your motor, should state how many poles your motor has. The motors I'm using, the Razorstar SIC2207s, have 14 poles. So that'll work out. This is the default setting. 5.5 is also the default setting, and for now I'll leave it as is. Over here the 8.8 kHz and 8 kHz wasn't default. The default was 8 kHz and 4 kHz, I think. So I know that this flight controller can handle 8K, like so. Maybe if you add a lot of peripherals, you'll have to throttle on back, but for now this will definitely work out. Okay, and accelerometer, I will probably never use it, but maybe in a blue moon I'll use the accelerometer when I want to land in auto level mode, but most likely I won't. I'll leave it as is though. And over here I changed the maximum arm angle if you want to ever use turtle mode. For instance, maybe if your quadcopter is stuck in a tree, you will need the maximum arm angle to be 180. Maybe your quadcopter is stuck in a tree upside down, and if it is, you won't be able to arm unless you have this set to 180. So I hardly ever use turtle mode when it's on the ground. I'd rather just walk to my quadcopter. Using turtle mode has the risk, you run the risk of burning out an ESC if you use turtle mode. So I only use it in a pinch. Okay, personalization, you can assign a name to your quadcopter and it'll show up in your OSD. And I haven't really thought of a proper name for my quadcopter yet. I've named it High Five. Yeah, okay. Okay, let's see. Receiver, again, we'll cover that in the next video. But in most cases your receiver will be a serial based receiver. And in my case it'll actually be an I-bus receiver. Maybe in your case it'll be an S-bus receiver, for instance if you use an FR-Sky receiver or an F-part receiver. We'll get to that in the next video. Alright, let's see. As of default, the default setting over here in the other feature segment is soft serial on. We won't be using soft serial, so I switched that off. Any of these features you switch on will take up resources, so don't just go ahead and switch everything on without reason. Telemetry, will probably be using telemetry. LED strip, LED strip, I'm not immediately, maybe later on. But well, if you want to use a programmable LED strip on your quadcopter, you'll have to switch this feature on. Display, no. Channel forwarding, no. Transponder, no. If you're running a racing quadcopter, you might need a transponder. Let's see, air mode. Yep, I'll have air mode enabled all the time. OSD, yep, I definitely want an OSD. Anti-gravity and dynamic filter, I'll leave those on as stock as well. And I won't be installing a physical beeper in the quadcopter. You can. If you are going to be installing a beeper, a physical beeper, then you should leave these two off. Again, I'll be using basically the motors as beepers, so in that case you'll have to switch these two to the right. And that is it for the configuration tab. So we'll hit save and reboot again. Alrighty. The next step we'll take a look at is the power and battery. And this is pretty simple. These are obviously at this point in time the default settings. And with these settings you see here, you can configure a couple of parameters which will influence what the flight controller will accept. For instance, the maximum cell voltage. Maybe you will be running high voltage LiPos. Then you'll need to change this because 4.3 is less than high voltage. So if you'd leave this as is and you'd hook up a high voltage LiPo, the flight controller might reject it or think that it's a different kind of LiPo. So keep that in mind. And a more important part of this screen is this over here, and that's basically the calibration of the measuring devices on your flight controller and ESC. See, they will measure your battery's voltage and the amperage draw. Pretty important. From the voltage you can see whether you can still keep flying or whether you need to land. Right, so that's important. Now again, these are the default settings for this flight controller. Is that true? Yeah, probably. But most flight controllers / 4-in-1 ESCs will come with specifications telling you to change something on this screen. And let me pull up the specifications of our stack, this Mamba stack. There's the documentation, and at the bottom, over here at the bottom, you see an amperage meter settings change over here at the bottom. So we'll have to copy that. Let's see the scaling and no offset. The scaling should be 115. So let's turn back to BetaFlight. Where's my BetaFlight? 115. The scale over here should be changed from the default 110 to 115. And no offset, and that should basically be it. After you've flown your quadcopter, you can calibrate this, and there are videos about how to calibrate these things. If you see that the figures on screen in your OSD are way off, you will definitely need to calibrate this. In general, I think the settings or the measuring devices of these Mamba stacks are pretty okay. But if you want them to be bang on, you should calibrate them. Okay, so I'll leave the rest of this screen as is. Yeah. And we'll hit save. Okay, the flight controller, as you can see, won't reboot after this save. That's okay. Okay, so PID tuning. We'll do that in a separate video. After we've got our quadcopter in the air, basically, we'll go and tune it. And there are a couple of things I want to point out in this screen, however. especially in the rate profile settings. As you can see in this column over here, everything is at 0, and especially if you're new to this, I'd advise you to set some expo. That'll make the quadcopter definitely easier to fly. So I would tell you here to enter 0.35 on every axis. That'll basically make the quadcopter a little less responsive at center stick, around the center of your sticks. Again, that'll make it easier for you to fly the quadcopter. And apart from that, I will change rates, this middle column over here. But for now, especially again, if you're new to this, just leave it as is. I will increase the rates significantly. Again, this is a personal thing, these rates. And after you've done like 1,000 flights or so, you'll know what the rates for you will be. Actually, that's a very important thing, the rates, but for now, just leave it as is. And then hit save over here. And we won't be doing any tuning until our quadcopter is actually flyable. Yeah. Okay, then the receiver. And again, that'll be covered in the next video. So for now, we won't change anything in this tab. The modes, we'll set up some modes. Let's set up some modes, and we'll set up 2 flight modes, 1 angle mode. I'm gonna be setting up angle mode on switch on aux 1. And if you are building along with me, well, just set it up on aux 1, and that's it. If my aux 1 is over here, so basically when my mode switch is in the middle or in the down position, it would seem like I would have no modes, but in BetaFlight that means you'll be in acro mode or in 3D mode or in stunt mode basically. And that is 99% of the time I'll be flying in acro mode, and you should do the same. Yeah, you definitely don't want to teach yourself or get familiar with flying yourself in angle mode, which means auto level mode. I do always add angle mode just in case I'm in a pinch. If I have a hard time landing the quadcopter for whatever reason, I add angle mode for that, and that's it. Okay, I do also want to add an arming switch. Oops, one arming switch, and I'll be using aux 2 for that. And I'll move that arming position all the way to the right, like so. So yeah, that'll be my secondary switch, and I'll use that same switch, aux 2, for my beeper. I always do this, beeper over here at range. So the same switch, aux 2, and that'll be in the middle. So with these settings, beeper and arming on one switch, I will have an audible confirmation that I'm using the correct switch. If I am not completely sure which switch is the arming switch, I simply move a switch to the middle position, and if I hear the beeper, I will know that'll be the arming switch. Okay, so that's the way I set that up. And let me see, yeah, the last mode I add is turtle mode, flip over after crash mode, and that'll be my third switch, aux 3, and I'll move that over here. And that's, you don't need turtle mode, definitely not. You do need arming mode, you don't need angle mode, but I'd advise you to at least add it in case you are in a pinch, and a beeper is highly advisable to add. And those are the modes I will be using. Okay, so that's the modes. Maybe I'll go into more detail in separate videos about every single one of the modes, but again, this is my basic setup. I'd advise you to well, copy paste this and you'll have a flying quadcopter. And motors. Okay, with this tab you can check if your motors run, but we already did that in the previous video in the setup and configuration of our 4-in-1 ESC. OSD, I will not be covering that in great detail in this video, but it is definitely advisable to add a battery, a voltage, so during flight you'll be able to see what the status of your flight battery is, right? And maybe a flight timer, and those will be down at the bottom. Timer 2, okay, move that to the side a little. Okay, and one thing you definitely do need is the warning. See, if there's anything wrong with your quadcopter, that'll show up as a warning. So for the bug fixing, maybe your quadcopter won't arm for whatever reason, you will see the reason for that in the warning. So definitely add the warnings. And the rest of the OSD is personal taste. Whatever you want. Maybe if you have added GPS, you will probably want to add GPS information to your OSD, but I won't. Okay, and then obviously hit save. And that's basically it for this video. The video transmitter I'll cover in a separate video. And black box logging is a black art in itself. Maybe I'll do a video on that, but that's highly technical and you won't need it to get your quadcopter in the air. And that's what we're aiming at in this series, at least up to now. And that's it for this video. I hope this was clear enough. And I hope it wasn't too long. Yeah, I am pretty sure that especially people that are new to this will be left with questions. Don't hesitate to ask. Hit me up a comment down below. I'll be able to answer you. Maybe other people will be able to help you. So yeah, don't hesitate to ask. Catch you on the next video. Bye bye.